So let's see what you guys came up with. So when you, and of course you can't show me remotely. Typically when we sketch these kinds of things out, people will use a mix of always-on availability groups, sometimes failover clustering. Database mirroring is kind of a tough thing to catch in here because, jumping back over to their requirements, I need to protect both with high availability and with disaster recovery. With database mirroring, I only get one standby or one replica, so it's tough to have multiple options in there. I might be able to do, say, a failover clustering across two data centers, have a cluster in one data center and a cluster in another data center, doing mirroring between them. Log shipping is going to be kind of tough here because although with 1 hour of downtime or 1 hour of data loss and 1 hour of downtime, you could theoretically do log shipping. Often in an environment like this, when you talk about a big enterprise and money is on the line, they usually have a 24/7 team of DBAs, like DBAs working on every shift. If there has to be a human being get sober and get to a keyboard, that's probably not something that I would be comfortable with. But if it's something that involves some kind of easy to accomplish task, maybe I'd buy it. This is a very common implementation for what I see out there. I see a failover cluster in each data center. So I have over in one data center, and in this example, I'm using Minneapolis and Chicago because this is an example of Discovery Channel's infrastructure. We talk about them all the time in class tuning. But I have a failover cluster on shared storage in one data center. So this is a SQL Server failover clustered instance that can fail over to either of these two physical nodes. Oh, good catch. Paul says the screen wasn't advancing, so here we go. So we have in one data center a failover cluster. So I have an instance of SQL Server that can fail over back and forth between prod 1 and prod 2 using shared storage. So I can fail over to either of these. Failover happens immediately. I say immediately, within 60 seconds with no data loss. I have one of these in each data center, and they're bound together in an availability group. Now, this is kind of complex. You can have a failover cluster that is part of an AG. That may not be what all of you designed. Maybe some of you did each one of these as individual nodes, each in an availability group, with synchronous replication going between each of these, and maybe async replication going over to two other nodes in another data center. That's fine too. I'm not saying that this is right. It's actually not right. But in order to figure it out, we have to go test it. We have to go sketch out a few things that are going to happen to our infrastructure. So the first test that we're going to have is, let's assume that the primary data center catches fire and we need to fail over to DR. Now that's not the test. You've already sketched out that you have an infrastructure in DR. The test is you have 60 seconds to write down what you would do before you let end users into that database. You've got an hour when you go to fail over. The catch is, what are you going to do in that hour before you tell people your database is good to go? I'll give you 60 seconds. Go. Okay, so you had 60 seconds to think through what you would do. Now, here's where the real test starts. After you let users into the database, 10 minutes later, a user accidentally truncates a table. Now remember, we have a commitment to the business that in the event of an oops delete, let me go hop back and show what that commitment was. In the event of an oops delete, I'm going to lose no more than 1 minute of data, and I'm going to be back up within 1 hour. Now coming back over to what just happened, before you went live in DR, did you get a full backup? Did you either have one from recently, like you were taking full backups in both data centers? Plus, do you have all of the log files required in order to get to that exact point in time? Oh, this is tricky. Whenever I let people into the database, this dictates the activities that I have to perform before I let them in. I may have to take a full backup before I let users into the database if I have to have oops protection, or I have to know where the full backup is and be able to get to it and restore it as quickly as possible. This is where utilities like Commvault and Data Domain can help. If I write my backups in one data center and they're automatically copied to another data center. Or I can do my backups to a Windows distributed file share. So my primary does the backup, and then it's available within a few minutes or hours on the secondary data center. I may also need to do, if I'm not taking log backups, say that I'm only taking log backups in the primary data center, because you can't take log backups in two locations. Let me rephrase that. You can take log backups in two locations, but you need all of those log files to be able to restore. So what we usually see is in the DR data center, someone's doing a full backup once a night, but as soon as we fail over to DR, we immediately take a differential backup so that we can use last night's full plus its differential and then start taking log backups from this point forward. I may not be able to let people in until that differential and first log backup completes. This starts to dictate how much time my failover is going to take and whether I need 24/7 coverage on the help desk. Because I can't guarantee a human being can get sober and get to a keyboard fast enough to connect into the VPN and then start this checklist. So that's scenario number one. By now, we might have learned a few things about how our infrastructure looks and what we're going to have to do to recover. Let's take scenario number two. Just like last time, we had a fire in the data center and then we failed over to DR. You went through the same list of checklists that you just went through a minute ago. You've already written down your 60 seconds of what you would do. But 10 minutes later, instead of a user saying that there's a table he dropped, a user says, I'm running selects and I'm seeing corruption errors. Now we have to ask a couple different questions about this. Where were we running CHECKDB? It's not enough just to run CHECKDB on the primary. I need a good clean copy in the secondary location as well. I need to have CHECKDB run somewhere in the DR data center. And remember what my RPO and RTO is. It's not a lot of time. If I want automatic page repair without doing a full database restore, I have to have a replica in the DR data center that gives me automatic page repair. Automatic page repair only works if there's a replica with a clean copy of the database there. And the only way I know it's clean is if I actually did CHECKDB on that guy. So the lessons that I learned out of this scenario 2 is high availability over in DR means that I also need some kind of other replica, whether it's database mirroring, AlwaysOn Availability Groups. If I want automatic page repair, I need something else, and I need to be doing CHECKDB over there. This also has impacts on my monitoring schedule as well. By default, a lot of monitoring software will just tell you if there's a database that hasn't been backed up anywhere. So for example, my production backups are happening in the primary data center, but I need smarter alerting than that. I need it to alert me if there's been no backups of fulls over in the secondary too. And I need to know that CHECKDB is succeeding every day in, every day in every data center. Now, it's up to you whether you do it on every single replica or not, although I would argue if a lot of these are sitting around idle just for protection, why would you not run CHECKDB on them every single day? So if I'm going to build in some kind of protection for this, if I want automatic, let's see, hold on, let me jump back here. Javier says, would you need to worry about database corruption if you were using SAN replication? Yes, because SQL Server has those bugs, remember. Check out in your RPO and RTO grid, in the corruption column, there are known SQL Server bugs where SQL Server will knowingly write trash data to disk. Now, do you need to worry about SAN replication or SAN corrupting the data itself? Yeah, I had a customer once who did a firmware upgrade on their SAN. And of course, when SAN admins do firmware upgrades, they usually do it on both sides. So they did it on their primary data center and their DR data center. Weeks later, their admins started noticing they were having more and more data corruption. They permanently lost data to a bug in the SAN firmware that they'd implemented. Every time SQL Server was doing writes, we were rolling the dice as to whether or not those writes actually made it to disk. So in here, what I've done is I've added a little more complexity in my infrastructure. Draw a line down the middle of the screen. Everything on the left is in one data center. Everything on the right is in another data center. So now I have a failover clustered instance here. This is the same thing I had before on shared storage. Then I have another SQL Server sitting right next to it that is not on the SAN. This thing's using local solid state storage because I want to be able to have corruption repair in the event that my SAN blows chunks. If something goes wrong with my shared storage, I've got to have some way to automatically protect that thing from corruption quickly. You'll notice that it's identical on both data centers. I have one on the left, I have one over on the right. That's because I need to be able to split this thing down the middle so that if anything, if I lose a data center on either side, I still have automatic page repair. This happens to be Discovery's infrastructure back when we first built it so that we could know we would get automatic page repair under any conditions, even if we lost an entire data center. Now this brings in some interesting questions, and some of you may have designed an AlwaysOn Availability Group as you built yours out. Where do you do your backups and CHECKDB? And do you want to offload them to a secondary? This is one of the most attractive features about AlwaysOn Availability Groups, and I know a lot of companies who got excited because they said, we'll go offload this work somewhere else so that we can go higher performance on our primary, so that our primary won't be slowed down by those backup and CHECKDB operations. Well, let's think through that. Let's take our next scenario. When your primary goes down, say at 10 a.m., what are you expecting to happen? What you're expecting to happen is that one of your secondaries will automatically fail over. Whether you're using a cluster or an AlwaysOn Availability Group, your RPO and RTO requires you to have zero data loss and automatic failover within 1 minute. Now, let's do real time. That didn't just happen. You lost the primary, and for some reason, the secondaries aren't taking over. You have 60 seconds. Write down what you'll do. Now, one of the most common reasons that this happens, everyone just assumes that always-on availability groups will automatically fail over if they're set up in synchronous mode, but that's not always the case. Now, of course, we talked about in earlier modules about problems around quorum, but that's not the only thing that will cause your AG not to fail over automatically. Check out this section out of Books Online, Factors that Disrupt Data Synchronization. Once all of your databases are healthy and synchronized, your secondary replica enters the healthy state. The synchronized secondary will remain healthy unless one of the following occurs. Your secondaries can automatically drop down into asynchronous mode temporarily, and SQL Server will never automatically fail over to something that is behind. Classic examples for this include network issues, Windows reboots, a SQL Server service on the secondary crashing or restarting, doing a memory dump, your redo thread falling behind. SQL Server 2012 and 2014, the redo thread is single-threaded per database, so it can get minutes or even hours behind if you're talking about tons of SQL Server activity going on. This is one of the things we're excited about for in SQL Server vNext. vNext allows that minimum replica commit that I talked about in an earlier module, saying, if you can't guarantee me that this transaction is committed across, say, 2 nodes or 3 nodes, do not accept the write. Just go ahead and fail. Because that way it's a lot like a DR scenario. I have a luxurious hour in which to fail over to my other DR data center. But as long as SQL Server is saying, yeah, I got your data, come on, bring it on in, all my other replicas could be dead or async, and I wouldn't know. Until SQL Server vNext, though, I don't have that capability. Synchronous AGs, just like database mirroring, do not guarantee zero data loss. Imagine if you just reboot those replicas, or if you have any one of a number of AG bugs that we'll talk about in the patching module, it's easy for those things to just simply restart themselves. So for us, we've been told that we have to get to this. We face financial penalties if we miss this number. Now, there's 3 ways that we could do it. One is that I could have an application simply watch all my secondaries, and if the primary starts to get way ahead of any of the secondaries, or if my secondaries aren't reachable, it takes down the primary and calls it a day. Now, the other way that I could do it is I could continuously do log backups. While 1 equals 1, take a transaction log backup and go restore it somewhere else outside of the availability group. That actually doesn't get me to zero data loss, because I could lose seconds or even minutes of data if things start to go wrong. It just gets me closer to having some kind of plan B for an insurance policy. There's another option. You could use a failover cluster. Failover clusters, because they have that shared disk, don't have to worry about always-on or database mirroring replication pieces. This is where SQL Server's failover cluster meets that absolutely perfectly. Now, granted, if I do lose the SAN, I have a bigger issue. But remember, a SAN failure is over in our DR column. When I talk about this SQL Server Seppuku, killing itself naturally, you can build degradation into your application. This is a screenshot out of Stack Overflow when one of their primary SQL servers failed. When the primary fails, the application goes and connects to its secondaries and says, can I still run read-only queries? And if so, it still renders the site just like you're seeing here. It says the site is currently in read-only mode, will return with full functionality soon. Visit or follow Stack Status, the Twitter account, or visit our status blog for more info. This is not something that's built into SQL Server. It's not built into .NET. This is left up to you as an exercise for the readers and the developers to automatically do this kinds of functionality inside the app. I've got a blog post about it down there. That continuous log backups, the reason why I like it is it's going to give me someplace else that I can go fail over to if the entire AG, like my Windows cluster, blows chunks. But where do I run those backups? Especially, look at your own design. Where did you decide to put your transaction log backups? If you offloaded your backups to a secondary, here's what that needs to do. First, ask, am I this primary replica? If so, is the replica that's supposed to do the backups more than a certain number of minutes behind? Like what happens if my replicas get out of sync? They're backing up out of sync data. If replication breaks between my primary and my secondaries, the secondaries will still happily do log backups for a period of time, but they're not backing up anything current. I, on the primary, have to say, oh, you know what? Those guys are more than 60 seconds or however long out of sync. I better go ahead and take a full backup here. Otherwise, if I'm the secondary, if I'm the one who's supposed to do backups, I should do it as long as I'm not more than a certain number of minutes behind. This is already kind of complex, and I've got some bad news for you. You actually can't check from the primary to see how far behind each of your secondaries are. This is a bug we filed that we first hit over on Stack Overflow, where under worker thread exhaustion issues, the DMVs that report how often or how far behind each of your replicas is, they simply stop updating and they report that 0 data needs to be sent over to the replicas, marked as won't fix. So I'm not going to be able to tell from the DMVs with a guaranteed business certainty exactly how far each of the replicas is. What I have to do is I'd have to build a linked server query over to every replica. And think about linked server queries. Those things got to time out. So now I'm introducing a latency into every one of my log backup jobs. This is miserable. If I'm going to do this, if I'm going to guarantee to the business, I'm not going to lose data, I'm not going to lose more than a certain number of data, what I'm going to have to do is take all of my log backups from the primary so that I can absolutely guarantee I'll always be able to have the data as up to date as possible in my log backups. But even that isn't going to be enough to cover everything we've got here. Scenario number 4. So my primary site goes down on a Saturday night, goes down at Saturday at 10 p.m. I have a fire or disaster in my primary data center. And I turn over to the secondary data center and I go to bring things up. And when I look at my canary tables, I'm 90 minutes behind. It turned out that some yo-yo was doing constant index rebuilds over on the primary, and that queued up a ton of data that needed to be sent to the secondary. But look what I have here. I've guaranteed to the business that I'm not going to lose more than 1 hour's worth of data. With SQL Server, there's no cap on time. You're either synchronous or asynchronous. And asynchronous equals behind. There's no guarantee about how far behind you can get. Here's where I have to start doing monitoring. I have to start saying that we're not just going to rebuild indexes because we can. We're not just going to go making wild and hairy changes to the database just because we can. I'm going to start pulling out queue tables or anything that gets rebuilt from scratch. Pull that out of the availability group and redo it in a separate database altogether. Then I'm going to have to monitor to see exactly how far behind each replica is. And when it starts to get behind, I have to raise an emergency with the network team to make sure that they fix it, because I can't. If all of a sudden we start to experience networking problems, there's nothing I can do from a SQL Server perspective once that pipe can't keep up. Last test that we'll go build on this thing. So in scenario number 5, I lose a replica. And let's say that it's in the primary data center. From the moment that a primary replica goes down, my log files on all of the replicas are going to start to grow. People think that all of the data has to come from the primary, and that's true, but who's going to be the primary whenever that secondary comes back up? Say that I have 2 replicas in one data center and 2 replicas in the other data center. I got to be careful with my fingers here. Say that this replica goes down. Now I have the primary sitting right next to him, and I have 2 other secondaries. Everyone's log files start to grow. Because what if we fail over and this guy is the primary when eventually this replica comes back up? Any of the replicas have to be able to seed that old replica that's dead, so everybody's log files grow at exactly the same time. Whenever I lose any replica, it's a mission critical emergency for me. And I like to set an alarm every 30 minutes while I'm troubleshooting a dead replica. This way, I can say, all right, an alarm just went off. Am I realistically closer to fixing whatever broke this replica? And how much space do I have left on my log file drives? If I start to run out of space, it may be easier for me to just simply remove this replica, put a bullet in him, and whenever he comes back, I'll introduce another replica back in. I'll add him back into this cluster. But I just may have to pull him out based on how large my log files get, how quickly. Great story out of there. We had one client who had an availability group replica fail on a Friday afternoon. The team was all heading out. They're like, it's a reporting replica. It doesn't even matter. Who cares? We'll troubleshoot it on Monday. And of course, all their index rebuild jobs and their data warehousing jobs immediately caused the log or the transaction log to be the same size as the database. They started getting out of disk space warnings because this log file just keeps growing on every single replica. There's another gotcha with whenever a DR replica fails. Remember that the replicas, whenever they have to come back online, they're going to get their data from whoever is the primary. Imagine for a second that I have a DR replica fail for 4 hours or 8 hours. When he comes back online, all of a sudden I'm just going to hammer that network, pulling all of the traffic down from whoever is the primary right now. When I lose a DR replica, it's often easier to say, you know what, I'm just going to take him out of the availability group and I'm going to reinitialize him using a full backup from a DR replica so that I can pull data from wherever was as close as possible and minimize the network traffic going back and forth between these data centers. When you think about the work that's involved with any one replica failing, you start to think about how can I get creative about getting him out of the AG as quickly as possible to minimize my log growth problems, and then get him back in as quickly as possible without saturating the network pipe going back over to my primary. Man, in theory, limited data loss is really easy. You just build a 2-node availability group and you call it a day. In practice, it's way harder than that. When you get to the point where you're going to tell the business, I will stand behind this, not lose data, and go down for only a certain number of minutes, you actually want to sketch out the entire infrastructure and then make several copies of it. For each copy, you pick, in this one, this guy's going to be the primary. Now, what happens when each piece of this dies? What happens when it's down for 30 minutes? What happens when it's down for 18 hours? What happens if it's just slow for 30 minutes or 18 hours? Classic example of a friend of mine who deals with availability groups, replication just started slowing down on one node. No one really knew why, if it was a hardware problem or a software problem. They simply had to take it out of the AG, wipe Windows, reinstall SQL Server, rebuild it into the AG, and then things magically worked fine again. As you sketch out all of these pieces of paper, then this starts to become your run book, your RPO and RTO design for how am I going to react when this piece fails? How am I going to react when this piece fails? Building out these run books makes the rest of your AGs way easier. The first one that's really reliable is tremendously hard. Fred says, AGs seem so much more complicated than I ever thought and make me want to avoid them in the future. That's one of the things I do try to drive home to people is that this is not the easy button. This is the hard button. It's awesome. It's tons of fun. I love pushing the hard button. But the drawback is when this thing fails, it's spectacularly challenging. And it's not like things were really that much easier before AGs. If you have to sign on a dotted line contract with someone saying, we're not going to lose more than X data or be down more than X long, it never was easy. It's always been hard. Some of the trendy NoSQL solutions out there do make it much easier, but they do that by taking away all kinds of features. Fred also asks, how frequently can you run SAN snapshots? The biggest problem with SAN snapshots is usually quiescing all of the writes. So writes freeze on that SQL server but depending on the SAN and its performance and its configuration, at minimum 1 second, but typically closer to 5 to 10 seconds. So businesses aren't usually okay with all writes freezing on the SQL server for, say, 10 seconds every 5 minutes. That's a quick recipe for blocking pileups.